It's an example from your textbook. You can pause this video and try to do it by yourself. First, try to find the point estimate of the mean and the standard error. So it is given that the x bar, which is the point estimate, equals to 2.51. The point estimate tells us where to center our estimate. So this is our starting point. The standard error will be calculated as the sample standard deviation 0.87 divided by the square root of a sample size. The standard error is the standard deviation of the sampling distribution of the sample means. This tells us how much variation we can expect between all possible sample means. Now we know everything but the critical value. We can use t-table to find the degree of freedom equals to 530 minus 1. We don't have such large degree of freedom in the t-table from the textbook, so we just use the infinity rows. And we are looking for the 95% confidence level. You will find the t-critical value equals to 1.96. And this is how we calculate the confidence interval. The margin of error equals to the t-critical times the standard error. And please verify this calculation by yourself about the 95% confidence interval. Simply plug in this formula here. The correct interpretation will be we are 95% confident that the true population mean, the number of children that is ideal for males, is between 2.44 and 2.58. We may change the level of confidence to 99%. Notice that the only thing that is changing is the level of confidence. Changing the level of confidence will change the critical value. So when we use t-table, we will still use the infinity row, but we are looking for the 99% confidence level. And the t-critical in this case is 2.576. Notice that the critical value is larger with a higher level of confidence. The margin of error is calculated as the t-critical times the standard error. Notice that the margin of error gets bigger when the level of confidence is higher. And please verify this calculation by yourself. It's about how to get the 99% confidence interval. Notice that the confidence interval is wider. Now let's find the 99% confidence interval. If the sample size was 51, not 530. So in this formula below, we notice that the sample size is changed. Changing the number of samples will change the critical value. So when we use the t-table, we are no longer using the infinity row. Now we are looking at the degree of freedom equals 50. And at the 99% confidence level, the t-critical will equals to 2.678. Notice that the critical value is larger with the smaller sample size. Changing the number of samples will also change the standard error. So now we calculate the standard error in this way. Notice that the standard error gets larger with smaller sample size, because when the sample size is smaller, this ratio becomes larger. The margin of error gets bigger because the standard error gets bigger. And please verify the 99% confidence intervals calculation by yourself. Notice that since the margin of error gets bigger, the confidence interval also gets bigger. Here is the StatCrunch commands you will use to get confidence intervals. You will have a chance to practice those commands in your lab section. Here is an example from a textbook. You can pause the video and read the question. Using knowledge we learned before the exam 1, we can easily get the sample mean, sample variance, and the sample standard deviations. Previously found the sample mean is 3.07 and the sample standard deviation is 3.38. So let's find the standard error of the sample mean. Recall the formula of the standard error. It is calculated as the sample standard deviation divided by the square root of sample size. Please verify this calculation by yourself. Now let's try to find and interpret a 90% confidence interval for the true population mean number of hours per week spent sending and answering emails. In this case, we know everything but the critical value. Again, we use t-table and we look at the degree freedom equal to 13 at the 90% confidence level. The t-critical will equal 1.771. The margin of error will be calculated in this way, and the 90% confidence interval will be 1.48 and 4.66. Please verify those two calculations by yourself. The correct interpretation will be, we are 90% confident that the true population mean number of hours per week spent sending and answering email is between 1.48 and 4.66 hours. We use StatCrunch for this problem. This will be the output. You can see it is very close to what we got by hand calculation.